We've already looked at the idea of refraction, and we're going to now combine the idea of refraction with the idea of these objects called lenses to see how lenses can be used to form images by refracting light. Now before we begin, we need to know a few keywords and labels. So the first ones we're going to look at are the names of these two types of lens. This one on the left hand side is called a convex lens, sometimes called a converging lens. And it can be drawn in one of two ways, either like I've done at the top here, or just with a simple straight line with a couple of lines at the top looking like arrows at the top and the bottom. The second type of lens is this one, and that's called a concave lens, and another name for that is diverging, and you should know actually both of these names for these types of lenses. And again, it can be drawn nice and simply with a straight line with the arrows facing the opposite direction, which makes it slightly simpler if you've got to draw it in an exam. Now a couple more labels that we need to know are to do with converging lenses, and we're only going to deal with converging lenses for this video. We'll look at diverging lenses separately, but what we have over here are two parallel light rays. So there's one over here at the top and one at the bottom, and when they hit the convex lens they change direction. The light rays will refract, and you can see they have refracted and they both meet at a point over here that I've drawn with a green dot, and that has a special name. That's called the principal focus. So the point where they meet on the other side is called the principal focus. We actually have 2 points where we can label as the principal focus. The first one is the one I just labeled there, and the second one is actually on the other side. So again, this is the principal focus, but this time on the other side of the lens, and both equal distance from the actual lens. The other label that we need to know is called the focal length, and the focal length is just the distance between the principal focus and the lens. So we go right to the center of the lens there. That's called the focal length, and you should be able to either label these on a diagram or recognize them, or actually say what distances they are. Now in our first example of formation of images, we're going to look at we're going to see how a convex lens can be used as a magnifying glass, and that usually works when we have an object here. So the object is just this little arrow, and it usually works when the object is in between the principal focus and the center of the lens, and we have a convex lens. Okay, now the way we do this is we have to draw in some ray diagrams or some light rays and see where they actually meet up. So if we actually do the example, that will become a bit clearer hopefully. So we have our object, and the first line that we draw is from the tip of the object straight across to the center of the lens, and then from the center of the lens the light ray gets refracted, but it actually passes through the principal focus. So there we have our first light ray. It's passed through the principal focus. Be very careful when you draw these. I've just done it slightly wonky, but it should meet properly there. The second way, the second light ray is drawn from the tip of our object here straight through the center of the lens where it meets the axis here. So it goes like this. Remember to draw in your arrows so that you know which way the light rays are going. And then what we have to look at is where the actual light rays meet. Well, in this diagram they're not actually meeting, but we have to find out the point where they meet, and the way we do that is we continue these lines on the other side. So the way we would do that is we'd use a dotted line, and we would continue the lines or the light rays on the other side of the lens, continue them like that, and see where they actually meet. And the point where they meet is where we can draw the point of our image. So here's our actual object, the object we're magnifying, and the image, the point of the image is there, and then we can just draw the rest in like that. So what we have here, in actual fact, that's often drawn as a dotted line because it's not actually a real image, and we'll talk about that in a sec. So here's our lens, and we've used it as a magnifying glass. Where would your eye be on this? Your eye would be over here. So you're looking at it from that kind of direction. You can see the light rays aren't actually going into the eye, but that's the position of where the eye is, and your eye would recognize or see an image which looks much larger than the actual object, and that's how a magnifying glass works. And you should be able to describe 3 characteristics of this image, and they are as follows. Okay, so the image is virtual, so that means it's actually not real. It's upright, which means it's the same way up as the object, and it's magnified. So when we use this lens to produce a magnifying glass, we produce an image that is virtual, upright, and magnified. And you should be able to describe these features of images produced by lenses. The second thing that we have to be able to do is work out the magnification. The magnification is just a very simple formula. It's the image height divided by the object height, and it has no units because we're just comparing one to the other. So in this case we have an image which has a height of 5, 10, 11, and the object height is 5, so the magnification is, well, that would be 2.2. So this image is 2.2 times bigger than the actual object. Okay, now the second way we have to be able to draw a diagram is when we have the object which is further away than the principal focus. So here's our principal focus, the object is much further away. Here's our lens. I've seen the lens drawn like this in an exam question, drawn very small, and this might confuse people because they'll be trying to draw the light rays through the actual lens. But what you can do is you don't need to work with such a small lens, you can just pretend it's actually quite long, and it actually works in exactly the same way, so that should make it slightly easier for you. So again, in the same way, we draw our light rays in, so it's going in that direction, hits the lens, goes through the principal focus, second light ray straight through the center, so it's the point of the object straight through the center of the lens where it crosses the axis, and the light rays meet there. So we can see that if we draw our object in, this time it's on the other side of the lens and it's upside down. And again, the 3 features that we should be able to describe for this are that it's real. And by real we mean it's an object that is produced by the real light rays. So the real light rays cross to produce this image. In our previous example, it wasn't the real light rays that were crossing, it was virtual light rays, so therefore we have a virtual image. So this one produces a real image from real light rays crossing. It's inverted, that just means it's upside down, and it's diminished, that means it's smaller. Okay, so these are 3 features of our image when we have our object which is further away than our principal focus. Now, one of the things I've noticed on a few past papers is that every time they've asked a question about lenses, they've always asked how you know the image is virtual or how you know it's real. And it's very important that you're able to say how this is. And the way we'd say it is that if the image is formed by imaginary or virtual light rays crossing, that means the image is going to be virtual. If the image is on the same side as the object, same side of the lens as the object, so here's the object and the image is on the same side, it's also going to be virtual as well. And for our real image, it's going to be on the opposite side of the lens, and it's where real light rays cross, so therefore we have a real image. Okay, and the last thing I just really want to say is that if you print out the PDF notes of this slide, or of these slides, here I've just given you a blank one to have a little practice on to see where you would where the image would be. And in actual fact, I'll probably just delete all these lines so that you can practice while you watch the video drawing the images for these different lenses here. That's me done for today's video. Thanks for watching, and I'll see you again soon.